Till now, we have seen today challenges. In challenges, the first point we are saying is heterogeneity, and we have seen that heterogeneity can be in several ways based on computer hardware, operating system, programming languages, networks. Even the implementations of the application softwares can be done by different developers at different sites, and because of that there can be some difficulties in implementing this distributed system, right? So I'm telling you about if such kind of heterogeneity is there. In these cases, if we have certain standards, some standard protocols on the basis of which these two systems has to communicate, in that case it is easy to implement distributed system. However, maintaining a standard is also a difficult task. Let me tell you about one thing, we call it middleware. Okay. So now, what middleware is? I should say it is a software layer that provides a programming abstraction as well as masking the heterogeneity of the underlying whatever these things are, whether it is network, hardware or operating system, even the programming languages, whatever these things are there. This heterogeneity can be masked by using a software layer, I should say middleware. Okay, if I have to write this thing, it is the same thing what I was telling you. So it is a piece of code, or I should say a software layer which provides what does it provide? A programming abstraction. So it provides a programming abstraction for what? For the underlying heterogeneous environment. So just wait a minute. The middleware, which is a programming abstraction, for what purpose? It can be a programming abstraction, or you can also call it as masking. No. Let me write it. A programming abstraction as well as masking the heterogeneity of all these things that we have seen, of the underlying, I should say, underlying whatever these possible heterogeneous things are there, maybe network, operating system, or hardware, programming language, these all the things can be masked by middleware. So what kind of this middleware be? What do we actually want from this middleware? How this middleware will work and how will it help? Anything that you want to ask about heterogeneity and the middleware? Questions? If you are not asking, I will ask you.
Hello.
Pradeep.
Good morning, sir.
Good morning.
Can you repeat middleware once again, sir?
Yes, I can repeat. So, middleware is just a software layer. What is happening here is you have your nodes. These nodes have to communicate among themselves. If there is a middleware, through this middleware you have to communicate. In that case, this is also software layer, no problem. In that case, what actually will happen, whatever operating system you are using, no matter, whatever programming language you are using, no matter, hardware is no matter, whatever you are using here is no matter, if you are transmitting something from node A to node B, you are converting the content to a standard format. Okay, and now this standard format is transferred to node B, and this node B also understands this standard format, and it can easily convert this standard format to its own understandable format. And later on, if B has to send something, it will also convert its own internal arrangement, whatever it has, to a standard format. And this standard format, as it is also understandable to A, it can be converted back to its own local format. Okay, so this is the purpose of middleware. Okay, so basically what I am telling you is, if we are standardizing some of the things using a certain software layer, we can call it middleware, so that the nodes can convert their format to a standard format, which standard format can be easily understood by the other node. Then it will be very helpful. I should say, then it will be able to mask the underlying heterogeneity. Okay, whether the heterogeneity is of operating system, that operating systems are different, whether the hardwares are different, whether the programming language being used are different, or the network topology, whatever they are using are different, or whatever kind of difference among these nodes are there. If we are using a middleware, a certain kind of a standardization, then we are able to mask the heterogeneity. Some of the examples, if I have to tell you, I can tell you about Corba. Have you heard about Corba? And maybe you would be studying Java. You would be studying Corba. Do you remember Corba? Corba. What is this Corba? It is Common Object Request Object request broker. Okay. So so Corba, this was used for standardizing your commands. You have to communicate among these things among the nodes. You would have heard about Java RMI. Let me write it. Java RMI, remote method invocation. So this Java RMI will also be helpful. For what purpose this RMI will be used? You can also understand with the name remote method invocation, which will support definitely the Java only, a single programming language. But you can call the methods of the objects on a different node. Okay. So such things are possible. Okay, now you can go through the book, you will find some more detail on these things. But still, for now, if you have some questions, please ask. Related to heterogeneity. To mask the heterogeneity, we use middleware. Definitely, in later chapters, we will see about some more on middleware. For now, to mask the heterogeneity, middlewares are there. Some of the examples can be Corba, Java RMI. Any questions for now? Nothing, right? Before moving further, let me tell you one thing about, I should say, mobile code. Have you heard about mobile code? What this mobile code can be? Can you guess?
Program.
Mobile code can be a program. Okay. For what purpose? Means its name is mobile code, which is different from the usual name. So what can be the difference between this mobile code and the usual program? Why is it called a mobile code? Definitely it is a code. Definitely it is a program.
Because it can be transferable from one to another.
Very good. So this is a code which can be transferred from one node to another, one computer to another, and which can be executed on that particular computer or node. For example, what happens in Java? You create a bytecode. This bytecode travels from one node to another, and there is a virtual machine. It can execute on that particular place. It doesn't matter what hardware it was, where it was written, or what operating system was, and whatever different things. But still, it is working for Java only. So means it will be, it may be language dependent. If at all you can generate a mobile code which is programming language independent also, that is also a good thing. Now we can go for next challenge, which can be called as openness. So we have seen heterogeneity, now we are going to see openness. Okay. So here in openness, what happens? It can be basically seen as whether the system can be extended and re-implemented in various ways or not. Okay, if the system can be extended or re-implemented easily, then it is more open. Okay. So that is the particular openness. If at all I have to write, I should write it determines So what does it determine? It determines whether a system can be extended and re-implemented or not. Whether the system can be extended and re-implemented okay. So now what this extension means, how these extension of the system can be done. One thing that you have to understand here, the extension word here is different from scalability. Later on, one of the challenge we will also see a scalability. Okay, here extension is only about the extension of services. Okay, whether we can extend the services, whether it is resource sharing services or any other services that is being provided by the distributed system. Maybe we are able to handle 100 users at a time. Now, can we easily extend this service for 200 users or maybe n number of users? So if we can easily extend our services, then we can say our system is more open. So that is our openness. Okay. Now we want to be open. We want to extend our services. Sometimes extending services may also require extending among the peers. We want to share our information. What informations? Like the specification and documentations of the key software interfaces. Okay, these information, if they are published and shared with others, then the other nodes can also implement and they can and then the services can be extended. But still we have to think about publishing these key interfaces. So It has always been a challenge to maintain a degree of openness in our distributed system. Okay. So basically, few things that we have to understand here is the key interfaces has to be published. This is H. So key interfaces has to be published. Now these published interfaces, this interface, whatever it is, it has to be maintained among all the nodes. Okay, all the nodes are maintaining using, I should say, these key interfaces for sharing the resources. Okay. Now also, if at all you are from different heterogeneous environment, even then how you have to use these key interfaces and maintain your mask your heterogeneity, that all the things come within the openness. So if you want to make your system open, it can easily extend or re-implement. For that purpose, you will have to publish all your key interfaces, I should say key software interfaces, so that the other new system can be implemented, or all of the nodes can implement using the same interface. Now after going through openness, we can see now about security. So now security is something that is very understandable kind of thing, that whatever information we have, we are sharing, whether it is stored information, whether it is a stored information or it is transferring information, right? Transferring information. Both the information needs to be secure. Okay. One thing we can understand is stored information definitely needs authentication to access. Okay. So if some kind of access is going to be done, some users are trying to access the information, there should be a mechanism of authentication, whether the authentic users are trying to access the data or not. If at all the data is being transferred, in that case we can understand, since the distributed system is a network, the data has to transfer from one place to another, and it may also move on internet. So such information which is traveling on internet, it is prone to attacks. Because of that, it needs to be secure, and for being secured on traveling data, one thing that can be done is encryption. So for this you can use authentication, simple username, password kind of things or something. Your data is being transferred, it can be like encryption, right? You will use encryption. Okay. So after knowing these things, some more attacks that are possible, let me name them. There can be, you would have heard about denial of service attack, DOS. Have you heard about denial of service attack? This is one kind of attack for which no concrete solution till now you have. Although several methods are there, several algorithms are available which are trying to detect the denial of service attack. But till now we don't have a concrete solution for this. Let me talk a little about denial of service attack before moving further. Let me ask you, do you know something about denial of service attack? Please answer, some of you. Do you know what is denial of service attack?
No, sir.
Okay.
No, sir.
Do you know what attack can mean in cybersecurity?
Shut down the machine.
Shut down the machine. Okay, attack is not only shutting down the machine. Attack can be anything. There is a server which is running. Server is providing some certain services to the users, and because of any reason correct services are not being provided by the server starts malfunctioning, or server stopped providing the service. These all the things including if some unauthentic persons are able to access the service, that is also an attack. So what happens in denial of service attack? Basically, the server which is providing the services is running. Okay, there is a server. Okay, what happens to a server? A client requests, okay, to the server, and server sends the response. Okay, during this process, when the request comes, before sending the response, a three-way handshaking is done, where some information is sent that we are requesting. Server sends an acknowledgement, and then one more acknowledgement is sent by the client. Then server understands and it sends the response. Okay. Till then, until this third something comes, information from the client, it maintains a queue, maintains the information of this client, and waits for the acknowledgement. Okay. Suppose the scenario this server is able to allow 1 million users, okay, at a time, because it knows at a time 1 million, more than 1 million users are not possible for our server. So it is maintaining a server which can handle requests of 1 million users. Now this client makes a request, and when this acknowledgement comes, client is not sending this acknowledgement. The server is maintaining some information and waiting for this client, and server is counting this request as one among this 1 million. Now suppose a scenario where this server receives this fake request 1 million times. Okay, if this server is getting 1 million fake requests, then all the capacity of serving for this server is full. Now these fake requests are not allowing a genuine user to access the service. Okay, so because these fake users, fake requests are there to the server is denying the requests of genuine users. Okay, so this is called denial of service attack. So this fake request, generating fake request to a server, is a kind of attack, because of which the genuine users are not able to access the services. So you call it denial of service attack. So in your distributed system also, you may have such denial of service attacks. Till now, we don't have a concrete solution for this. However, different possible solutions are going on and being provided in the literature. Some of the machine learning techniques are also being implemented for this particular thing, for denial of service attack, and also distributed denial of service attack, when not only one client, multiple such clients are together sending the request to the server, right? So now this is also a challenge for your security of distributed system. Now another thing was your mobile code, as you have seen. So for security purpose, you will also have to secure your mobile code, right? Security of mobile code. Okay, what does it mean? We have also already seen what a mobile code is there. It is transferred, it can be transferred from one node to another to execute. So when we are transferring something from one place to another, we understand that there is a risk, right? So we will have to handle it with care. So you can encrypt it, or some kind of thing that can be done to make it secure. So the next thing that we will see is scalability. Before moving further, let me ask if you have some questions. So students, if you have some questions, please ask. Okay, let me repeat what we have seen today. We started by revising the last class, where we have seen the definition of distributed system, and some more information related to distributed system and some of the characteristics, and then we move toward the challenges. We have seen heterogeneity, and heterogeneity, where then there can be differences among the nodes based on network, hardware, operating system, programming language, or any other thing, which can be masked with the help of middleware. We have seen the openness, where we try to understand whether the system can be extended or re-implemented easily or not. For being extended or re-implemented easily, it is important to publish the key software interfaces publicly, or maybe at least to the implementing nodes. Then we came for security, where we understood that whether the data is stored or being transferred, it needs security. If at all it is stored, somebody might try to access, and these accessing users should be authentic. So we should have an authentication mechanism. If the data is traveling, we should encrypt the data, whether the spelling of encryption is correct or not. Some other kind of security issues are also there, which can be denial of service attack. We should also take care of this, till whatever extent we can do. Security of the mobile code is also important. If at all we have a mobile code, then we have to make it secure as well. So these are certain things that we have seen today. Now, any question if you have? No questions? Do you have any question? Okay. Then what I am suggesting is you should go through the book, read the books. Also, you should see the examples. There are several examples. Although I have named only a few examples, there are more examples in book. Go through those things. You will understand about distributed system. And then again, read all these things, challenges. There are some more challenges we are going to discuss in next class. So you should study those things also. Studying these things beforehand will help you understand better. Now, I think the next class will be on Thursday, 11 o'clock. For now, you should remember these things in the next class. I may ask about these challenges that we have seen today. Let me take the attendance as well. And